Okay, this is the 1MZ FE V6 again here on the Toyota. This is the 94 model. It's one of the first years they put this engine in here. It's an OB2.
It's the first year of the OBD2.
Yeah, but 94 is a experimental year, or sort of new introduction year. So not even the scan tools go back to 94. They call it OB1 for 94, but it's really an OB2 for this particular engine. So this car has to be read on a scanner as a 96 in order to get any kind of scan codes off of it. But this was to do a quick sensor overview again for coolant temp sensors and other sensors, mainly for coolant temp sensors. I had a guy ask a question about having a temp sensor down on a radiator somewhere. I'm looking down and I haven't found anything attached to the radiator itself that has any type of wiring harness on it. There's nothing concerning any wiring harness connected to the radiator itself. Now I could be wrong, but I haven't read anything on a 94. It's not to say a 98 or 99 or any of those years don't have that sensor. Let me see in the front. Anyway, quick rule of thumb on the OB2, which is more involved, computer controlled involved. It's more electrical gadgets and crap. What
is that? Right there on the right side of the radiator.
Where?
Oh, yeah, is that a line?
Yeah, that's a what you call it line. That's an AC line. That's a condenser core. Anyway, all right, let's get down to it real quick. Okay, we have one cooling fan on a 94, just one. It also operates off the power steering hydraulic fluid. I guess somehow the power steering fluid cools the fan motor to keep the fan motor lubed and good to go, which is pretty cool. I haven't really encountered that on an automobile. But anyway, back to your sensors. Your coolant fan, if your coolant fan's not working, it's not coming on, then you need to test it. You need to see if the fan actually works. So the first easiest way to do it is just turn the AC button on. Just press the AC. Turn the AC on, and automatically your fan should kick on. Now, with the AC off and the fan's not coming on at all, then start checking your sensors. After you establish that the fan is good, the fan motor itself is good, then you start checking your sensors. Now, your sensor to cut your fan on for this particular engine, as you can see, we changed the injectors and everything back in there. We pretty much went through this whole engine. We have other videos coming out later on all this. Where's our sensor at for the fans? Right here on this side, right below, right there, this brown one, below those vacuum lines, right there. That sensor right there sends a signal back to the ECU and also controls the fans. Now, if you unplug that wire, your fans should come on. They should stay on when the key is on. You'll throw a code, that's alright. Your fan will stay on. Now, your other sensor, just for the PCM itself, or the ECM, to tell it to run to tell it to run in a closed loop or open is right here. That's another sensor, same as the other video. That's what they refer to commonly at the auto parts store as a cooling temp sensor. This sensor right here is a little one-wire sensor. That controls the gauge only. That is for the gauge only. So it's a little bitty sensor, but it's a one-wire plug. So that goes to the gauge. So in essence, test your fan. If your fan's not working, then you got a problem with the fan. You can do that by pushing the AC button and see if the fan comes on, like I said, or you can unplug that sensor on the driver's side of the engine. If you unplug that and the fans kick on, then there's an issue with that sensor, generally. You can always reset the computer and see what happens after that. You pull your ECM fuse, and you pull it for about 10 seconds, 15 seconds, and plug it back in. Or you take your battery terminals off, touch them together, put them back on. Don't touch your battery together, but touch your terminals together to discharge the power. And see what code you get after that. Now, as far as like a shuttering, or what I refer to as a miss, because a lot of people confuse a sputter with all kinds of different things. Usually that's a miss. The only thing that I can see a coolant, the only way I can see a coolant temperature sensor making an engine miss is as if it's running in a closed loop situation and it's flooding the shit out of the spark plugs. I mean, dumping massive amounts of fuel on the plugs, and you would smell it coming out of the exhaust. It would be running rich. It would be running like crap, especially when it warms up, and that would cause your engine to miss, because spark plugs would be fouling out with fuel, and then it would systematically get worse as you ran it, because you'd foul one plug, then you're still spraying with that injector, and then another plug happens after that, and that injector keeps spraying, and then it just keeps on going and going after that. So it just gets real bad. I've had those problems on foreign and domestic vehicles. Generally, if your engine is missing and you have these external coil packs, even though it's not throwing a code for a coil pack, it doesn't mean the coil pack is not on its way out. I can't tell you how many times on many different vehicles that a coil pack was bad, and I did not know it because it didn't throw a check engine. But I had to go through the engine systematically. I had to have somebody hold a foot on the brake and keep it in drive so the car would shutter, have a miss to it, and then I would have to pull one coil pack wire at a time until that particular one didn't make a difference. When that particular one doesn't make a difference under a load, sometimes you have to have somebody step on the gas pedal and bring the RPM up to about 1500 with the car in drive, with the parking brake on, with somebody holding their foot on the regular brakes, just to find out if it misses, and then to be able to isolate which coil pack is actually missing. And sometimes it's just moisture inside of the boot, but 9 times out of 10, if it doesn't clear up after the engine warms up, it's actually the coil pack. The coil pack is weak and creates a problem. So there are some tips there. Also, an EGR valve. An EGR valve will give you, an EGR valve does nothing at an idle. It remains closed at an idle. But when you put the car in drive, the EGR valve is activated. EGR valve is here. This is your EGR, and you got your valve, and it opens and closes. You can put a vacuum line on it, test it, see if it opens and closes. EGR valve will cause an engine to idle funny. It'll run rough. Sometimes it'll run like crap. You can test it yourself. You can pull this vacuum line off, stick another external hose on here, and just create vacuum with your lips, and put your tongue over it and hold vacuum pressure on it, and you'll see how bad the engine actually runs. That's what would happen if your EGR was sticking In other words, when you're in drive, your EGR valve is open and closing and throughout a driving cycle. But when you're in park and you're idling, your EGR valve should be closed. But sometimes EGRs get stuck slightly open and they leak, and they cause the engine to run like crap, cause it to feel like it's missing, but it's not missing. So that's another confusing issue, is an EGR. So your EGR should be closed at an idle in park, and when you put it in drive and you start moving, your EGR should start working accordingly as part of the emission control system. So, or exhaust gas recirculation, whatever you want to call it. It's all the same family. So it's for the same purpose. You know, it's to go green, it's to save the planet, whatever bullshit. So the EGR is important to look at if your car is missing and running rough. Now it's an easy test. If it opens and closes fine and good. Now if you put a vacuum line on here and you bring it to your lips or to a vacuum gauge and it won't hold any pressure, then your EGR valve is bad. The diaphragm and it's burned out. It's defective. It's got a hole in it. So that's another thing. So these are different things you want to look at. Most of all the sensors and parts on this engine have been replaced, and it runs great. However, there's a funny issue with it. It seems to run like crap when you first start it up upon acceleration. In other words, it doesn't run like crap. It doesn't have the acceleration it should have when you're first taking off. Well, I've noticed that the temperature gauge takes a little while to warm up. When it does warm up after, a little while, it runs great. And I've always wondered, what did we not replace on this engine that would make that difference? I mean, we replaced the ECM in this car, and we replaced almost everything, every sensor there is. But we were wondering what could be the problem with that. We replaced the fuel injectors, replaced the fuel pump, we replaced everything, just about. And if we didn't replace it, it was thoroughly tested. So we've come to the conclusion that we think the thermostat is stuck in an open position, ever so slightly. So the water's constantly circulating. So what that's doing is, by the way, the thermostat is way down here, somewhere down at the bottom of, it's right there, down there at the bottom. You gotta take all this crap off to get to it. Anyway, I bought another one and I just don't feel like taking all this shit off to replace it yet. But my point is that there's a duty cycle for the thermostat, and because the water's constantly circulating and it doesn't have a chance to stop because the thermostat assumingly is stuck partially open, it takes, number one, forever for the engine to warm up to operating temperature, causing it to run like shit. The reason why is because the sensors aren't getting that proper reading. The heater in the car works decently, but it seems like it should get hotter faster. I've been in vehicles, foreign vehicles, domestic vehicles, where the heaters work within the first 5 minutes of running the vehicle. This one takes a little longer. So that's the reason why I think the thermostat is not closing all the way. So the duty cycle of a thermostat is to open. I mean, at first is to start off closed. That means the water in the block gets hot. Gets real hot, heats everything up. Then it opens. Puts the hot water and trades places with the water in the radiator, which is cold. Goes to the engine. That cold water cools the engine down. And then the water in the radiator is hot, and the radiator and the fan combined with moving speed plus the fan cools that water, and then the thermostat opens again and does the cycle again, and that's called the duty cycle. So it just continues to do that, open and closing, open and closing. Well, if the thermostat's stuck open, guess what's happening? The water's always staying at one temperature. And the only way that the car would run good is if it were to open all the way. Have its natural duty cycle, open and close. Now, if you get a thermostat that's opening all the way when it gets hot, but not fully closing, letting too much water circulate at one time, it would have an effect where the car would not overheat, like this one does not overheat, but my fan is not running at full speed when it should. My sensors aren't telling my PCM accurate information, and it takes forever for the heater to warm up. And it runs like shit when you first accelerate. In other words, it has poor acceleration when you first start it. So we're going to tackle that thermostat next, and I bet you, without even taking it out, that it's not closing all the way. In other words, it's stuck not halfway open. It's not stuck. It just will not close all the way. It reaches a certain point and it doesn't close all the way, but it opens all the way. So I bet when I pull it out, I bet it'll be stuck in sort of a partially open position. So we'll find out. So that's another issue that will throw your sensors for a loop. It'll feed inaccurate information to your ECM, to your PCM. Because it's not performing its proper duty cycle. Now this thermostat has no whatchamacallit, but do note that this sensor, oddly as it may seem for the fan, is attached to the thermostat housing. How about that? What if there's constantly warm, lukewarm water, cold water, or lukewarm water rushing through this?
Now explain why the fan doesn't run at full speed.
Exactly. Because this thermostat is not closing and allowing this sensor to read hot to turn the fan on full blast. This is nothing more than a switch.
For that fan right there.
That's it. That's all it is. It's an electronic switch that works off of ground.
And I guess relays some info back to the PCM.
Right. It also relays back to the PCM information. So the ECM is trying to compensate for that because this is this PCM is pretty advanced. I mean, I tried to get Toyota software. We can't even get software to program this ECM. Toyota will not release that information. We could do it on Fords. We could program shift points and all that, but we can't do that on this engine. Even though this is a 94, Toyota won't give up the rights. So we can find some bootleg stuff out there, but I don't trust any of that. I'll fry a PCM or something or mess everything up. ECM. So this is just a little explanation of what may be wrong with your vehicle if you feel it missing or it's not running properly, and some of the things to look out for. So that covers kind of like the EGR, that covers a thermostat. It kind of explains the importance of it, and it also says that first-hand knowledge. I mean, I own 5.4 liters Fords. I own 4.6 liter Fords. These engines all have external coil packs, and they can go bad without triggering a check engine light. And they're not dead, they're just weak, and weak enough to miss sometimes. Sometimes they miss all the time, and they don't throw a code. It's only when they die completely, some computers are sensitive enough to pick that up off of the crankshaft sensor, positioning sensor, usually on most vehicles. That feeds back, that they're responsible for telling the ECM that the coil pack is bad on most engines. I haven't read up on Toyota yet, but it does have a crankshaft positioning sensor. It is responsible for telling things like that, that the plugs, that the coil packs are not functioning right. But it doesn't always pick it up. I mean, I've had them on 5.4 and 4.6 liter Fords. Never throw a check engine light. Never. And it's just the way it is. So unfortunately it's going to be trial and error with unplugging different coil pack wires. You can just unplug the wire, leave the coil pack in. and just see which one does not make a difference. And you'll notice, you know, sometimes you'll have to go back around and around again. I understand it's probably be a pain in the ass behind the intake, but you can still unplug those wires. Now, I would try it and see, but first I'd see if my fan works. That's important. If the AC makes it come on, great. If it doesn't, then check the fan itself. Check the motor and the fan, see if the fan's faulty, and then go from there. Don't assume that the ECM is bad, because my other ECM is good. It just has a different, it just acts differently. It has maybe have been programmed for a different region, possibly, so it acts differently. I find that the ECM in it now, the way that it's programmed, its factory default program, it seems a little bit different. I know they're supposed to be all the same when you get the same part number, but they're not. So I like the ECM that we put in it now, because it gives you a hell of a punch. I'm getting maximum performance out of the stock V6. I'm probably getting almost every bit of almost 200 horsepower. So that's just a little, you know, lowdown on some of the things that we talked about. And maybe you should check it out and perform some of these shade tree techniques. Okay, peace.